What's going on, everybody? James here from Artificial Entertainment, and welcome to another Unreal Engine 5 tutorial. And today we're going to be looking at some advanced line trace usage. So let's go ahead and open up a project and dive in. So I have here a third-person template project. Now, a couple of things I do want to advise before we move forward is that this is a project file in Unreal Engine 5.1. However, I discovered this system in 5.03, so I know it works in both. I'm just using 5.1 primarily because there are a couple of different things that you can do with the new input action system that you can't necessarily easily do in 5.0, so it's just some things I'm going to add in at the end, but everything that I'm going to be showing you today is accessible in 5.0, 5.1, and most likely 4.27 because it's utilizing nodes that have been around for quite a while. Now, the second thing is this whole tutorial is going to be based off of just showing you two examples of what you can do. However, there is an infinite number of possibilities that you can do with the system. It's entirely up to your imagination. What I'm basically showing you is a more effective way to use line traces to be able to create complex traces off of a single execution. That's the goal of today's tutorial. So we're going to go into the third person blueprints and BP third person character. Now, one thing I always advise is that if you're setting up line traces, especially for something like motion warping or anything that's going to be like a complex trace with a few different variables you're going to save but only use them for the purposes of that trace, sometimes it's better to set them up as functions rather than trying to set them up in the graph themselves. So we're going to use the function section to be able to actually create our line trace. So we're going to go functions, add a function, and we're just going to call this line trace. Alright, so now the first trace I'm going to show you guys is what's referred to as a 3-point trace. There's a trace that goes out from the target forward, and if it hits something, there's going to be 2 additional downward traces, and we're also going to do an object detection trace. So something like you would use for motion warping for a melee combat attack, it will give you 2 motion warping locations, as well as a check that's going to see if there's anything in the way when you try to warp. And again, we're doing this all off of single execution. Now, for single execution complex traces, realistically, there's 2 things that make this entire thing work. So the first thing is we'll pull off the line trace and we're going to add that first one in, which is a for loop with break. So the for loop with break essentially allows you to loop a section of code and you can choose the index value for how many times it loops. So for example, if we set the first index to 1, and we set the last index to 10, it's going to perform 9 traces. However, if we set this to 11, it'll perform 10 traces because we're setting our first index to 1, which I do recommend doing. Even though technically speaking, 0 is a value within the system of code, I found issues when you set the first index value to 0. So if you set it to 1 and then just set the last index to 1 above however many traces you want, you'll have it work just fine. Now from here, this output index value is going to be one of the most useful things to make sure this all functions properly. And we're actually going to want to right click and we're going to promote it to a local variable. And this is why we wanted to use the function, because this way this local variable doesn't get messed within all of our main variables for whatever you're coding within your game. And we'll just take this and we'll name this line trace index. Now you want to make sure to hook this up off of the loop body because we want this to update every single time the index value updates. So if it's going to start at 1, then go to 2, 3, 4, and so on until it reaches 11. We want to make sure that this variable updates every single time that the value updates. Now from here, off of the set here, we can just pull off and we'll get the standard line trace by channel. Now this is really all we're going to be doing. From here, it's going to be just setting different vector values for the start and end. Because as I'm sure you guys know, when you're trying to set up multiple traces, like something to go to and from the target, and another one is a downwards, and another one that's a back and forth, usually you'll need multiple traces to do that. But there's actually a way to be able to control which vector value is going to be input utilizing something called a select vector. So we'll get to that in a minute. It'll make more sense in just a moment. But the first thing that we need to do is get our initial trace. So this is going to be the trace that's going to go forward from the character, and that's the standard line trace. So we're going to right click and get actor location. Right click again, get actor rotation. Pull this back here, pull off of the return value and get the forward vector. And then we'll pull off of the forward vector here and we'll multiply it, changing that bottom node to a float single precision. And we'll set the value here to something like 400, just so that way it goes out far enough from our character. Now, one thing that this system does require is you split out your start and your end locations. So while the get actor location is going to be the start, and get actor location in addition to a rotation value is going to be the end, we're going to duplicate that actor location. So this way we can keep this separated from this. And then from here, we're just going to pull off get an add node, and hook these up together like this. So this way we have our end and our start. Now what we can do is we're going to take these, pull them down a little bit, and we're going to get our line trace index value. We're just going to get a get node, not a set node. So my bad. And off of here, we can pull off, and we're just going to get an equal. So we're going to see if our index for our line trace index is equal to 1. So this is going to be the first thing we do. And we'll just take this and we'll duplicate it because we'll need 2 copies of it. Now here's where we use that select vector I was talking about. So if you pull off the get actor location and just type in select, you'll see select vector as an option here. So we can click on this and you'll see we have 2 input values for vectors A and B, and then we also have a Boolean value for pick A. So this is where using this can actually be really awesome to create some really cool line traces. So we're going to take this index and we're going to plug the Boolean value into pick A. So if it's equal to 1, we're going to pick A. And if it doesn't, we're not going to choose anything because we haven't given it any values for B. Now this is going to be important later, but just make sure don't hook anything up into the B value. Now we'll take the select vector, duplicate it, and again, we're just going to plug this output into A and this Boolean value into pick A. So this way, if it's equal to 1, and again, that's what we set our first index as, so this is going to be the first thing that it does. Now I know it looks a little weird from your standard trace, but if we go ahead and plug these into the start and the end, and change our draw debug type to for duration, compile, and we just set up a quick keyboard event E just so we can do something to call our trace. And I'll just go ahead and bring our line trace function off of pressed like that. So again, this is just setting it up a little differently. I'm just showing you guys that if I hit E, we now have a trace that goes out in front of the character going 400 units forward, just like your normal line trace would be. So now this is where we're going to start getting clever and making it so that we can use this single execution to perform a more complex trace shape. So the first thing we want to do though is we want to perform like a validation check to make sure that if we hit something that, we're able to set the values. Now again, this is mainly if you're trying to make it so that way if you hit something, continue forward. There's also another type, which I'm going to show in the second example, where you're not going to actually use the if it hits to cancel it out. But for right now, for this one, we want to make sure that it hits something before we continue on. So we're going to go off the return value for out hit, and we're going to add a second branch with B and left click, and hook the true up into that branch. So basically, if we do hit something, what we also want to verify is if the line trace index is equal to 1, because we want to make sure that we're only looking and setting off of that first trace, because this is going to be the one that allows everything else to flow. So I had to clean up my graph a little bit there. But now, so if this is true, what we're going to do is we're going to take the out hit, break the hit result, expand it, and we're going to take the impact point, pull it up, and we're going to promote it to another local variable. And this one's going to be initial impact location or impact point, whatever you want to name it. We'll just go initial impact point. We'll go into here, off of true, just like this. Now, because of this, though, we also want to make sure to go off of false. We'll just duplicate it. And then if we don't get a hit, we're also going to, just check and make sure that we are within that first index value, because if we don't get a hit on other things, we don't want to cancel out our information. So off of false, go into the branch here. And again, this is just if we don't get a hit, checking to see if our line trace index is equal to 1. So off that first trace, if we don't get a hit off of that first trace, we're going to make sure to set initial impact point back to 0. And then we're going to take this execution pin and we're going to plug it into the break, because this is going to be the thing that allows us to be able to control if we do or do not continue on with our trace. And this way, values and information don't get left behind, because we want to make sure that anytime we're setting information, we also have the ability to reset said information as well. So now that we have the ability to set our information if our first trace is hit, and if it's not hit, we're resetting everything. What we can do now is use a very simple node to be able to give us more position. So I'm going to take all of this, we're going to move it back, and we're going to get another select vector. We'll just copy the select vector and the line trace, but this time we're going to see if our line trace index is equal to 2. And we're going to undo the return values here, and we're going to plug this into B. So we want to make sure that the one before it, the select vector that's hooked into the next vector select, is hooked into B, because this way, if it's not equal to 2, it's going to choose B. But if it is equal to 2, it's going to choose a different value. And this is where you can use this to chain these different vector selects together and have multiple different options for different things that it can choose from. And these are realistically the two main things that make this entire system function: select vectors and line trace index. But from here, we can actually use something called a lerp node to be able to actually now define a point between the two locations. And that's why we wanted to make sure to set this if we hit something. So what we're going to do is we're going to take that initial impact point and we're going to get a reference to it. And then we're also going to get actor location. Now from here, we're just going to pull off the initial impact point and grab a lerp, and you'll see lerp vector. Now what a lerp is essentially just allows you to be able to define a point between 2 points. So if I hook these two up into here, and if I just scroll over, you'll see linearly interpolates between A and B based on alpha. 100% of A when the alpha is 0, and 100% of B when the alpha is 1. And you can set values in between, like 0.5 if you want it to be right in the center. So, and that's actually what we're going to do here. So we're going to take this alpha value, set it to 0.5, and then we'll just take it, drag it down a little bit, and we'll plug this into A. Now we're going to take this and duplicate it because we're going to use essentially the same value, but we're going to make one mega change, or one minor change that makes a mega difference, I guess, however you want to look at it. But we'll plug this return value into B, and I just copy that select vector because, again, we're just basically copying the same stuff and just changing the line trace index equal. So it's going to be equal to 1, it's going to do these two. If it's equal to 2, it's going to do these two. But what we're going to do off of this lerp vector is we're going to take it and we're going to subtract, go to the Z value, and we'll just subtract 150. Now, this value you might want to play around with a little bit, just so that way in case there's like terrain angle differences that you don't want to make it so that way, like if they're like completely off a cliff edge or something like that, that they're not able to get the point. So play around with that Z value, but it's really just up to whatever you need. So now what we can do is we'll just take the select vector, plug both of the return values back into the start and the end since we've added in one more point, and go ahead and click play. And now what'll happen, you'll see that we get the single line trace that goes out, but nothing else happens. But if I go and turn around and I hit this, you'll see that now we get a trace going down directly in the center. And I can be closer to it, and it's still going to be directly in the center because it's getting a linear interpolation between the two vectors and then getting the half point. That's what I've set it to. So now what we're going to do is we're going to change this value. We're going to change it to 0.2. On both of these. So that's one thing. You do want to make sure that both lerp vectors are the same value because this way it'll make sure it's straight up and down. If one's different than the other, it'll create kind of like an angle. But what we're going to do is, again, we're going to unhook the start and the end here, and we're going to add another select vector. This time we're going to see if it's equal to 3. And then again, we're just going to take this, highlight it, duplicate it, move that down a little bit, and then we hook it up again. And as you can see, there's literally a straight pattern to this. It's just getting the select vectors, a Boolean value to control which vector is being selected, and then using that nice lerp2 node to be able to actually set the point on the line itself. So what we're going to do now is basically the same thing, but instead of setting the lerp value to 0.2, we're going to set it to 0.7. And that's all we're changing. We're going to copy the exact same vector values, except the only thing we're going to change is changing that lerp vector to 0.7. Because again, at 0.2, it's going to bring it closer to the actor, and a 0.7 is going to bring it closer to the target. So we'll take this lerp vector, plug this into here, make sure that we have our subtraction node in here. Accidentally didn't copy that. Now, you do, with all of these nodes, it is a good idea to try and make sure you keep your graphs clean. I usually take a lot of time to try and keep this all very neat, but it does take a little bit of time to properly clean up. So just keep that in mind. There's a lot of things going on. But what this allows you to do is set up single execution line traces, because if you have any frame drops or any lag spikes or anything like that, and it's right in the middle of two line trace executions, and they're both needed to be able to get information for an action that you're trying to complete, sometimes it can cause problems. But if you can set all of your traces up off of a single trace execution and just have them do different things like this, it will actually allow you to do more. Because now you can see we've got the same value, but we're going to set this value to 0.2 on this one and 0.7 on the other one. So we need to make sure to set this to 0.7. Oh, no, not 7, 0.7. All right, and then we'll compile and save. We'll go ahead and just minimize this really quickly, and we'll click on play. So now if I go and I turn around again, we get the line trace that goes out, doesn't do anything if it doesn't hit. However, if we do get a hit, now we've got 2 points. And again, it's getting a value of 0.8 for that first one, or 0.7 for that first one, and a 0.2 for the other one. So we've got these 2 locations. So now for the last part here, so now we've got a check to see if we're actually hitting something, If we are hitting something, we're going downwards and getting 2 additional impact points. So the last thing that we need to do to be able to complete this is just add in that check to make sure that there's no obstacles within our way before we actually perform the trace. So we're going to go ahead and just unhook the start and the end here. And this is where we're going to change this value here that the Boolean is being selected. So we can take this and duplicate it, but we're going to take out the is equal and change it to a greater node. And we're going to see if it's greater than 3. So you want to make sure that it's set to be greater than the previous value that you set. So this is 3, so I want to make sure it's greater than 3. So that means 4, 5, 6, all the way and so on. So we'll take this, plug this into pick A, and then we'll take this and duplicate it. So this way we can have a start and end position, and we'll plug up B into both of these sections. So now there's a way that we can use the lerp vectors in combination with our line trace index to now create a multi-trace that's going to happen. Now, you guys might have seen something like this in the motion warping tutorials on YouTube for like vaulting and things like that. But we're actually going to work this in to the last thing it's going to do at the very end of our first trace. So we can take the line trace index, so we'll grab a get node, and what we're going to do is we're going to take this and we're going to multiply it. But we want to make sure that the output here is of a different value. So we're going to take this and multiply it by 5 for right now. Now, this is essentially going to be the gap, because we're going to have multiple traces happen at once, and it's going to make more sense in a moment, but this is essentially going to be the distance in between all the traces that are going to occur. So we'll set this to a value of 5, but then on the execution pin here, we're going to right-click, convert it to a vector value, right-click it again, and we're going to split the struct pin. Now, we also want to get an add node as well, but we're going to go ahead and grab this lerp vector first, and we'll just push this out of the way, because we're going to take this lerp vector and we're going to add it to this. So we're going to pull off the lerp, get an add node. We'll plug it into the bottom pin though. We don't actually want it on the top pin, because we're going to right click on the top pin and split the struct pin. Now, why it is that you have to do this and have both of them split, I don't know, but I know that this is the only way that it works. So make sure that the split on the multiplication is done as well on the addition node, because then from here, you can plug in the 2 Z values like so, and then plug this into the A for select vector. And now what we'll do is we're going to take this entire section here, and we already actually have the select, so we don't need that. And we're going to duplicate it, because we're going to use essentially the same code. We're just going to change the lerp's value. That's the only thing we're going to change. So we're going to take this one, plug it into the A, and we're going to set this lerp value to something like 0.7. And the top one here, we're going to set to 1, because we want it to start at the actor location and then go forward out. Now, you can set it to whatever value you want, but I'm using 0.7 because what's going to happen is it's actually going to stop right at where we set our last location for. And this will make sense in a moment. But we'll go ahead and plug in the return value of this into the start, and we'll plug this into the end. Now, we also want to make sure to change our trace index from 11 to 5, because otherwise it's going to create a ton of traces. And we don't need that many. So, but now if we go ahead and hit play, and again, single trace goes out. If it hits nothing, doesn't do anything. However, if we go and we hit, we now have 2 traces that are coming out. But as you saw, the traces are a little high, and we're also, we're not going forward because we set that lerp wrong. And that's my bad. So we'll go ahead and we'll fix that, because we're going a value of 1, and then instead of value of 0.7, we're going to set this to a value of 0.3. And we also want to make sure on the multiplication, we're going to set this to -5 instead of 5. The reason why I started at 5 is because I wanted to show you guys the difference between using a positive and negative value. Because now, if I go again, we get the single line trace, turn around though, now we got 2 traces that are going from the bottom and going down. Now, what we can do to be able to adjust this is we can add, instead of 5 traces, we can go and we'll do 8 traces. And instead of -5, we'll do -10. And this is, I'm just showing you guys like what values to play around with to be able to kind of get the fine-tuned adjustments that you're really going to want. Because again, I'm just playing with single values and then hitting play. And then just going up and hitting a wall. And now you can see we've got multiple traces happening, and it's really stopping it right about knee level. So the only thing I would want to do now is maybe increase that lerp value. So this way it'll go more towards the initial impact point. So we'll set this to maybe like 0.1. Then again, we'll hit play. And then it kind of goes a little bit past. So this is where, again, you just play around with the value of the lerp, and whatever works for you, works for you. But again, now we have multiple different traces happening. If it doesn't detect anything, there we go, 0.2 worked. If we don't have anything happening, we can see that now we're just doing an object detection and we're getting all of our initial information. But again, this is all happening off of a single execution. So, and this video did run a little bit longer, so we're going to do the next trace style in the next video, where we're going to show you how to be able to do it without having an initial impact point, as well as being able to choose like vector change, like left vector, right vector, for things like corner detection and stuff like that. And realistically, this is the main part of everything, just utilizing these select vectors with a Boolean value and using the line trace index value to be able to set which value it's actually going to use. And out here, you can use whatever index value. So like, for example, if I wanted to use motion warping and I wanted to set 2 and 3 as my locations, I could go, when we get an out hit, I could just do if the line trace index is equal to 2 and equal to 3. So we go 1 branch for 2, 1 branch for 3, and then it goes and, sets a warp location, warp target 1, warp target 2. So there's a lot of different things that you can do with this system, but again, the key thing with this is that it's all off of one trace. You don't have multiple traces going off, and if a hiccup happens, you're going to end up with issues in your code. This allows you to be able to have a little bit more of a complex check, but more efficient data within your actual game itself. So I hope you guys enjoyed, and again, I apologize that we're not going to get into the second one. I just don't want to do an hour-long video, so we're just going to cut it off here today, and then the next video, we're going to go over how to be able to do a different version of the same type of system. So if you guys have any issues, please let me know. I'm always active in the Discord, I'm always checking the comments, so if you guys have any issues with this, please just let me know. But that's going to close it out, and as always, guys, stay animated.